What's up guys, and welcome to the 20th tutorial in my PHP backend. And in this tutorial I'm going to show you how I did the actual implementation of building the route tree. So I'm going to start by looking at this function, get route tree. And this is the function that builds the whole tree from this variable. And here it is. So the first thing that it does is collect all the routes from the routes. It collects all the endpoints, and it uses the URLs. So it iterates over these, and then it gives each URL to a function called asTree, and what that does is it explodes on slash, so it'll be an array from the URL, and this recursively builds a subtree of the URL. So the first thing that it gets is a route, and then the tree, which is the array that it's going to build. And this is how default parameters works in PHP. If you don't give it a value, you don't have to specify tree, which you don't the first time, and then it'll be initialized to an empty array. And also the ampersand symbol here, it's a notation that I want to pass it as a reference instead of creating a new copy each time. And I do that because I want side effects, and also I want to pass it as a reference because I don't want to make a new copy every time I iterate it, so it'll be a little bit more memory efficient. You got to be careful with passing stuff by ref, because strange stuff can happen, you know, when you edit them in the body of the function. So the first thing that I check if the route, the length of the route, if there is any route left, and if there is, I'm going to set the key of the tree to the first index, and then I'm going to recursively call it and taking away the first part. So for example, in the example that I showed you here, it's going to, you can think of it as a loop. So the first time it'll check if what the count of these are. So in this case it's 4, so it's going to be greater than 0, and then it's going to set the first from the first index, so color, to the tree. So the tree will look like this, and it'll have color in here, and it'll continue iterating. So then I'll use slice to remove the first part. So in the second iteration of the recursive function, it's going to look like this. So it's going to continue setting the tree recursively. If I do all the iteration, and then the last time the count will be 0, and we hit the base case, and the base case is after the else, and then we're just going to return the tree. But this isn't the whole story, because this will only give us a subtree from the URL, so it only give us one URL from this route. So what I do is I iterate over all of the routes and get them. We can have a look at how they look. So I created a subtree. So this is the first one where the last parameter is the name, and this is the second one where the last parameter is gravy. So then I just merge them together recursively, and this will give us a combined array of all the routes. That's going to be the final route tree. So you can see that they are combined. In the last iteration, they have appended all of it, so they're They're merged together. And this is also what's getting returned from the function. So that gave us the whole route tree. And it shouldn't be too complicated. Recursive programming can be a little tricky, and you can run into something called a stack overflow exception, because every time you call the function within itself, it just adds one callback to the memory stack. And if that stack gets too big, you run out of memory. And especially if you don't have a base case, because then it will be infinite, and then eventually you're going to run out of memory, or a stack overflow exception. And because there is a preset amount how big the stack can get for each application, it depends on the environment. So you can run into that problem theoretically, but I'm gonna assume that you don't have that many routes. I'm gonna assume that you have don't have 1,000 routes and just a handful, I don't know, maybe 100 at tops, and it should be fine. But we're not looking into optimizations here. If you do run into problems with the recursive, you can flatten it out to be iterative instead if you like. It's just like you get cleaner code with the recursive stuff, and also you can look into the problem if you run into it, basically. This is the first naive implementation, basically. And then when we have the whole tree, we want to get the route from the tree, and you can do that by calling the getRoute function. So I just give it the tree, and then I give it the URL that we got from the client, and I give it also a function called variables, which is defined here, and it's set to empty. So in the getRoute function, and I do this just because I want to pass it as a reference, so I need to define it outside because it can only return one value, and I want to accumulate it over time. So this function is a little bit more tricky. So you can see I pass the tree by ref, and also I pass all the parts, and then I pass the variables by ref, and then I have an accumulator that I also mentioned. So the tree is going to be the whole tree structure. We're going to iterate over this into the subtrees, and the parts is going to be the parts that the exploded URL from the client, and the variables is going to be the accumulator for the get variables, and this accumulator is going to accumulate the route from the tree as we go along. So the first thing that I check if we hit the base case and if the array exists. So if there isn't any parts left in the URL, we're going to go into this section here. In here I just accumulate the routes that we're iterating. So let's see how the accumulator looks. And you can see that it's basically like adding them together. And then I call recursively with the next subtree that we're going into, and we remove the first part from the parts array, and we pass in the variables. We didn't do anything with this yet because we didn't hit the variable in the URL. And we also pass along the accumulator. That'll be a little bit bigger this time. So it'll call itself until it reaches this part where it doesn't match the URL. And if the count is bigger than 0 and the key doesn't exist in the tree array that we built from the routes, it could be either that they edit something that doesn't exist in the routes, or it's a variable. So what we do is we check at this subtree level, we iterate over all the keys and see by regex if we if we hit the variable, basically. So you can see the curly braces here, we're checking for that. And if this matches, it means that we hit the variable. So here I do the exact same thing, but I accumulate the key from the subtree instead. And also I push the value from the parts at this level into the variables array. And then I call recursively to the next part, and then I do the same thing. I take the subtree from the key that we're using, and we slice away one at the beginning of the parts array, and then I pass along the variables. That should be one variable bigger this time, and also the accumulator that I accumulated with the curly braces stuff. And eventually we're going to hit something else, and this means that we hit our base case. Either we can't find anything, or the URL was wrong, or anything. And this is where the iteration stops. And this is just for removing the first slash, because when we iterate it, we add a forward slash to it every time, because we're building an array, building a URL. And if we don't do the trim and remove the first slash, it's not going to match the routes array up here, because it looked like this instead. And if we do like I did here and add a forward slash, the result would be 2 forward slashes. So it doesn't help to add them up here. So we need to remove the first slash. And then eventually we're going to be able to return the accumulator. And this is when all the mapping is done. And then we will basically pop all the callbacks on the stack, and eventually we'll end up with the route key if it matched, and then we are back to square one where I described in the previous tutorial. So that's basically it. And I know that recursive programming can be a bit tricky to wrap your head around, so I suggest that you just take your time. I've commented everything with the parameters, what they are, and the critical sections in the functions as well should be commented. So I suggest you, if you haven't already, I suggest you clone the project from GitHub. There is a link in the comment section, so you can clone it, and then you check out the branch, which is pt20 for part 20. So check out that branch and just like do what I did, var dump every time you don't understand anything, so you understand how stuff is built together and see how it actually works, and try to fiddle around with it and see if you can make any optimizations that you like, or just like trying to wrap your head around the recursive stuff. So I hope you guys enjoyed it, and I see you in the next tutorial.